Okay, now we're at the point where we're ready to graph these logarithmic functions. And so what's already been mentioned before that is that the logarithmic function is just the inverse of a exponential function or vice versa. And so if we look at our logarithmic function right here, that's the same thing as what y equals log base 2 of x. And if we were to convert that to exponential form, it would be 2 to the power of y equals x, right? And then to complete the invert, to create this into the inverse, you swap the x and y. And so then you'd end up with y equals to the power of x, which I have right here. And I have the table for it. And so that's kind of the one of the easier ways to graph these is what you do is you find the inverse because it's a little bit easier to work with to come up with a table of values, and then you just switch them. You just switch the x and y values because that's part of the definition of an inverse function is that the x and y are going to be switched. And you can see that on the graph right here, these ordered pairs. If you were to flip-flop the x and y values, so this is at 2, 4. Now you have it at 4, 2 over here, right? 4, 2. So this one was at 2, 4. And then now this one's at 4, 2, right? And that's true for all the points on the graph right here. Another thing about logarithmic functions is that they're going to have a vertical asymptote. And so the exponential functions had a horizontal asymptote, but logarithmic will have that vertical asymptote right there. So let's just go ahead and jump in and do a couple of these, and I don't think you'll find them to be too bad, especially if you're good at graphing the exponential, then you shouldn't have too much trouble with the logarithmic. So right here it says graph the following logarithmic functions and include the vertical asymptotes and the range. That should actually say domain. Sorry about that. That was a typo. So we want to actually find the domain because the range on all these is from negative to positive infinity. These logarithmic functions go up and down indefinitely. So the domain will be limited. So we need to list that. Note the boundary value of the domain is where the vertical asymptote is located on the graph. So the boundary value of the domain. So if you remember from the previous video, what we do is we take this part right here and you just say, okay, that needs to be greater than 0, right? Because we can't evaluate logs at negative values. And so that is actually where my vertical asymptote is going to be. It's going to be at x equals 0 in this first example right here. Okay, so now what we're going to do is we're going to change our function notation to y equals log base 5 of x. Okay, and then what we'll do is we're going to convert this to exponential form. And so now what we'll have is we'll have base to the power of y is equal to x. And so we should hopefully be fairly familiar with that conversion. And then now to find the inverse, um, we are going to swap the x and y. So we're going to find the inverse. We're going to swap the x and y. So now it's going to be 5 to the power of x equals y right here. Now this is the inverse. So I'm going to make a little note of that. This is the inverse function. So what we'll do is we'll come over here and we'll make a little table of values. You don't have to find a bunch. We're actually going to keep it fairly simple. We'll find negative 1, 0, and 1. So when I plug in negative 1 right here, we get 5 to the negative 1 power, which then actually will become 1/5. Then 5 to the power of 0, which becomes 1. And then 5 to the power of 1, which becomes 5. Now, these are actually my values for the exponential function, right? But I want to find the inverse function, my logarithmic function that I began with. So I'm going to come over here and I'm going to make a new table. I'm going to swap them. And so I'll call this x, and we'll call this f of x so I can remind myself that this is from this equation. And by definition of inverse functions, the x and y swap places. So this will be 1/5, and then this will be negative 1. This will be 1 and 0, and then 5 and 1. And so let's go ahead and plot those. So the 1/5 and then down 1, so that'd be about roughly right there. Then we have a point at 1, 0, about right there. And then at 5, 1, about right there. And then we'll just go ahead and I go along my asymptote right there. And then here I just go up a little fairly slowly, just like that. And that's it. And so my domain on this one is going to be from 0 to infinity. All right, let's move on to the next one. So here, once again, I'm going to change this to, or let's find the domain real quick. So we'll take x plus 1 needs to be greater than 0. We'll subtract 1 from both sides, and so I get x is greater than negative 1. And so that is where my vertical asymptote is going to be located at x equals negative 1. So now we'll go ahead and switch from function notation to y equals log base 3 of x plus 1. Okay, not too bad. Then we're going to convert this to exponential format. So the base raised to the power of y equals x plus 1. Okay, and then what we want to do next is swap our x and y. So I'm just going to write inverse just to remind myself that we're finding the inverse because we haven't done the inverse yet, but now we are. So now my inverse is going to be 3x equals y plus 1. And then last, we want to go ahead and subtract 1 from both sides. So we're going to have 3 to the power of x minus 1 equals y. And so that is the inverse. That's going to be my inverse. And so what we'll do is we'll make a little table of this and then swap them. And that will be my table for my actual original function that I had up here. So here's x, here's y. So once again, I probably don't want to get too crazy with the numbers I pick, so I'm just going to pick like negative 1, 0, and 1. So when I plug in negative 1, it's going to get a little messy. So I'm going to have negative 3 to the power of negative 1 minus 1, which then becomes 1/3 minus 1. And if you were to put that in your calculator, it would come back as negative 0.66 repeating, or you can convert the 1 into a 3 over 3, and you can get an exact answer of negative 2/3. So either one of those is good. Then the other two should be pretty easy. So let's see. 3 to the power of 0 minus 1. Well, that will become 1 minus 1, which equals 0. And then let's see, 3 to the power of 1 minus 1, which would just become a 2. So you don't want to plot this table because if you do, this is for the exponential function right here. But we want to plot its inverse. And so to do that, we're going to have to flip-flop these. And so over here, I'll make a new table for x, and I'll call this one f of x so we can recognize it from the original function. And give myself a little bit more space. And so let's see, we're going to swap this. So now this is going to be negative 2/3 to negative 1. And then here 0 to 0, so those actually match. And then let's see, then 2, 1. And so we're going to plot these points. So negative 2/3 or negative 0.66 backwards. And then we're going to drop down to negative 1, so roughly about right there. Then we have 1 at 0, 0, and then 1 at 2, up 1. And then we'll go ahead and connect those dots right there. And there we go. And then the domain, we really already found the domain, but we're going to put it in interval notation. So my domain is going to be from negative 1 to infinity. Okay, let's look at a couple more of these. So looking at example C here, what we're going to do here is let's go ahead. The domain here is going to be x is greater than 0, so that's where my vertical asymptote's going to be is going to be at x equals 0. And then we're going to change this to y equals log base 4 of x minus 3. And then our next step has been to convert to exponential form, which we will do, but I can't do that until the log is isolated. So I can't have this minus 3 here to do my conversion. So I'm actually going to have to add 3 to both sides first. So I'm going to end up with y plus 3 equals log base 4 of x. Now I'm ready to convert it to exponential form, which would be 4 to the power of y plus 3 is equal to x. Okay, and then now it's time to write the inverse of this. And so we have to swap the x and y. And so we're going to have 4 to the power of x plus 3 is equal to y. And so that's the inverse. And so we're going to find a little table here. Now this time you're going to have to think a little outside the box because I don't want to use negative 1, 0, and 1. I want to pick values that are going to make my exponent those values, negative 1, 0, and 1, right? So I'm trying to think to myself, how can I make this a negative 1? Well, I'd have to plug in negative 4, right? So erase that. But when I plug in negative 4, that will actually make the power negative 1. So I would get 4 to the power of negative 1, which then is the same thing as 1/4. Then I'd want to plug in negative 3, which then would give me a power of 0. And then that simplifies to a 1. And then last, I want to do negative 2, which would give me a power of 1. And 4 to the power of 1 is 4. Now, once again, that's my table for the inverse of what I'm actually graphing. So now it's time to come up with my table for the actual function that I'm graphing. Once again, I'll use the function notation since that's the only place that we actually had function notation for that. Okay, so now we flip-flop them. So this becomes 1/4 is paired with negative 4, and 1 is paired with negative 3, and 4 with negative 2. And then we'll go ahead and plot that. So over 1/4 down 4, which put us about right there. Um, over 1 down 3, which would put us about right there. And then over 4 down 2, put us about right there. And we'll go ahead and graph this going down and curving up. And that's it. Last thing I'll do is put my domain in interval notation from 0 to infinity. All right, we'll just keep on going. So example D now. So once again, let's see, my domain is going to be greater than 0, so my vertical asymptote is right there at x equals 0. And so we're going to go ahead and write this in terms of y. So y equals negative 2 log base 3 of x. And then once again, what we're going to want to do here, first we have to isolate the log part of this. So we're going to divide both sides by negative 2. So this one's going to be kind of interesting. This is maybe not even one that we saw when we were doing exponential, graphing the exponential functions, but I think we're going to be okay. I don't think this should give us too much trouble. And so now we're ready to put this in exponential form. So this would be 3 to the power of y over negative 2 is equal to x. And then to find the inverse, oops, let me fix that. To find the inverse, we are going to go ahead and flip-flop those. So we're going to have 3 to the power of x over negative 2 equals y. So yeah, this is probably something we haven't quite seen when we were graphing exponential functions, but it really should not give us too much trouble. And so when we make this table here for x and y, what we'll want to do is plug in some values that will give us -1, 0, and +1 for our exponent right there. So to get -1, I would just need to plug in a 2, right? So 2 divided by -2 then would give us 3 to the power of -1, which then gives us 1/3, right? Then I want to pick a value where I'd get 0. So that would be pretty simple. That would just be 0. Sorry about that. I keep getting interrupted. Okay, so let's see. That would give us 3 to the power of 0, which then would give us a 1. And then we want to plug in something that would give us a +1 for a power. So we plug in -2. So -2 divided by -2 would give us 3 to the power of 1, which is just 3, right? So that's for if we were going to graph an exponential function, but we're actually graphing the inverse, the logarithmic function. So what we're going to do is make a new table right here for x and for f of x, my original function, and we just switch them. So now it's going to be 1/3, 2, 1, 0, and then 3, -2. So let's see, that first point is right here. Then the second point's here, and then our third point is right there. And we're good to go. And then the domain, once again in interval notation, is going to be from 0 to infinity. Okay, let's go ahead and do one more, and then we'll make a secondary video for this. So on this one, let's see. So we're the domain on this one's going to be kind of interesting. So you have x is going to be greater than, I'm sorry, -x is going to be greater than 0, and so we don't want -x, we want +x. So we're going to divide both sides by -1, and whenever you do that, you have to reverse the inequality symbol. So this is going to be actually become x is less than 0. So that's going to be kind of interesting. Now, my vertical asymptote's still at x equals 0, though, right? It's still at x equals 0, but you notice my domain is values less than 0, so my graph is actually going to be over here. And so technically that negative in front there is creating a reflection of the graph. So the graph should reflect somewhere over in this region. So once again, we'll kind of follow the same pattern we have so far. So y equals log base 5 of -x, okay? And then we'll switch that to exponential form. So that would be 5 to the power of y equals -x, okay? And then we are going to switch the x and y, but the negative stays where it's at. So don't do anything with that negative right there. And so what we're going to end up with is 5 to the power of x equals -y. And obviously we don't want -y right there. So what we're going to do is basically divide both sides by -1. But be careful, that doesn't actually change the 5 to a negative, okay? Because the power gets to go first in terms of order of operations. So what you're going to want to do, there's a couple different ways you could write this. But basically, I'm going to write this as like -1 times 5 to the power of x, because that's how it would look if we were doing exponential functions. And then the y would become positive. And so the point that's being made here is the negative does not get applied, because I could have multiplied both sides by -1. It's the same thing as dividing both sides by -1. Just causes a sign change. But the sign change cannot occur until after the exponent has been applied. And so you have to make sure you apply the exponent and then the negative. So then coming up with a little table of this should be fairly simple for x and y. So we're going to plug in -1, 0, and 1, and it should work out pretty nice. So we do have that -1 right there, and that's going to be times 5 to the power of -1. And so then that's going to become -1 times 1/5, which equals -1/5 right there. Then for 0, let's see, we're going to get negative 1 times 5 to the power of 0, which then is going to equal negative 1 times 1, which equals negative 1. And then for positive 1, we get negative 1 times 5 to the power of 1, which then is just going to equal negative 5. Then we come up with the inverse table, right? Because this is my inverse function right here. And so if we want the table for what we're actually supposed to be graphing here, now we can just swap them by using the definition of inverse functions. So negative 1/5, negative 1, negative 1, 0, and negative 5, 1. So let's see, negative 1/5 and then down 1 would roughly be about right there. Then at negative 1, 0 right there. And then negative 5 up 1 would be about right there. And we just kind of curve this and go along our guardrail, the asymptote right there. And that's our graph. And then the domain in interval notation, this time be a little careful. It's going to be from negative infinity to 0. So that's going to be the domain on that one right there. Okay, so I'm going to go ahead and cut the video here, but I do have a couple more to go, but we'll just do that in our next video.